Yes friends, welcome once again to the class. Let's move on towards our next topic of discussion, that these are the questions which need to be solved. Let's look at these particular questions. That using single particle shell model, predict the ground state spin and parity of the following things. Okay, so number one is your aluminium 1327, then it is your sulfur 1633, then argon 1841, then carbon 612, nitrogen 716, carbon 613. Okay, so these are the nuclei for which you have to find out the ground state spin and parity, and that too using nuclear shell model. And nuclear shell model is your single particle model, as already discussed in the previous classes. So using this single particle shell model, we have to predict the ground state spin and parity of all these nuclei which have been given to us over here. Now number one is aluminium 1327. So let us see aluminium 1327. Let us see the nuclear configuration right now. Okay, so Z equal to 13, clearly aluminium 1327. So Z, that is atomic number, is 13, and number of neutrons will be what? Number of neutrons will be 27 minus 13. Okay, number of neutrons will be 27 minus 13, and 27 minus 13 is equal to what? 27 minus 13 is equal to your 14. Okay, 27 minus 13 is what? 14. So this is the number of neutrons over here, and number of protons is 13 clearly. Now as the number of protons is odd, as already discussed in the previous lectures, that the number of protons over here is odd. Just a second guys, just a second. So there is some disturbance over here. Okay, so as the number of protons is 13, which is an odd number, and number of neutrons is your 14, which is an even number, so no need to write the nuclear configuration with respect to neutron. No need to write nuclear configuration with respect to neutron. Why? Because the 14 neutrons will pair up with one another and will give you zero spin. Okay, the spin on account of neutron will be zero. Spin on account of neutron will be zero because the number of neutron is even, so they will pair up. Okay, and it will yield you zero in total. Okay, so the 14 neutrons are there, so they will pair up like this. Okay, all of them will pair up like this because of being an even number. Okay, so this is the thing. And Z equal to 13, that is your number of proton is odd. So as the number of proton is odd, what will happen? As the number of proton is odd, so the nuclear configuration should be written with respect to proton. Number of proton being odd, the nuclear configuration with respect to proton must be written, so that ground state spin and parity are found out. Okay, so that ground state spin and parity are found out. So that's why we must write nuclear configuration with respect to proton, as the number of proton is odd. So the shell model terms of the nuclides are given by, so the according to nuclear shell model, how to write the nuclear configuration, about that I have already told to you, right? Already told to you. Now we have to write out the nuclear shell model of the nuclides. Okay, so this and for this is for proton. Okay, because only number of proton is odd over here, so we will write the nuclear configuration with respect to proton. So let us write that. So 1s 1 by 2 2, 1p 3 by 2 4, 1p 1 by 2 2, 1d 5 by 2 5. This will be the nuclear configuration of aluminium with respect to protons. Okay, this will be what? This will be nuclear configuration of aluminium with respect to protons, right? So it will be like this. Now as already told to you in the previous lectures, I have applied the another convention. There is one more convention over here. Okay, there is one more convention. What is that convention? The other convention is that actually we can say over here it will be 2 according to other convention. Over here it will be 2 and over here it will be 2, and then this will be what? This will be 3. Okay, according to that convention. The other convention about which we had already learnt in the previous lectures. If you haven't watched the previous lectures, then I would suggest you to go to the link in the description. There is a playlist in the description link. There is a playlist, and in that playlist, if you go to the 4 or 5 lectures prior to this, their nuclear shell model has been started from the very beginning. Okay, or if you want nuclear and particle physics lectures to be itself from the very beginning, then what should you do? You should watch from the very first lecture then. Okay, then you will understand each and every concept very clearly if you want everything from the very beginning. Okay, I have started from the very basics and I have reached this advanced level up to here. Okay, so the other convention also I told you. So this is according to the convention. In some books this convention is used, and in some other books over here 2, over here 2, and over here 3, such convention, that is the shell number. Okay, in some books the coefficient, okay, the coefficient in front of spectroscopic symbol, all these are what? 1 1 1 1, all these ones, 1 1 1 and 1, these are coefficients before the spectroscopic symbol. SP, DF are what? Spectroscopic symbols. And this 1 1 1 1, all these are what? All these are coefficients. Okay, all these are coefficients in front of spectroscopic symbol. Okay, so this is the thing. Now the thing is that if we write according to other convention, then the coefficients will become 2 over here, 2 over here, and 3 over here. Why? Because in that other convention shell number is taken. Okay, so this is the first shell, so it will be called 2. Okay, and this is the other shell, right? So this is, as it is other shell, so it will be written as 2. Okay, second shell has started as 2 nucleons are filled up. Then what will happen? Then the over here it will be third shell. Okay, and over here P is being repeated once again. Okay, I think it is not P, it is something else. Okay, it should be P only. Okay, so it will be 3 because P has already been taken over here, so it is another P over here. Okay, so all these things are there. So you can yourself check with the help of nuclear level diagram. Okay, nuclear shell model. In that I have told you the energy level diagram. Okay, so in that energy level diagram you can look at that energy level diagram and you can correspondingly write the nuclear configuration with respect to proton for aluminium. You can easily write that. Now the thing to be observed over here, what is to be observed? The thing to be observed over here is that in this particular subshell it is even number of nucleons. In this particular subshell also it is even number of nucleons. In this subshell also it is even number of nucleons. And in this particular subshell it is odd number of nucleons. Okay, so the thing you should do is that only consider this particular shell, because it has what? It has unpaired nucleon. Okay, so out of the 5 nucleons which we have over here, 1, 2, 3, 4 and 5, it will be like this. So one nucleon remains unpaired. Okay, so the ground state spin and parity will be decided by this unpaired nucleon. Okay, by this unpaired nucleon, that is unpaired proton, it will decide the ground state spin and parity in this particular case. Now I am warning you that if you haven't watched the previous lectures, then this particular lecture is of no use to you. Okay, because you won't understand this particular lecture then. Okay, so you should certainly watch the previous lectures. Now for neutrons, what will happen? Actually there is no need to write the nuclear configuration for neutrons, but still I have written and showed it to you. I have written it and shown it to you just for practice purpose. Okay, it is just for practice purpose, so it has been shown to you over here. So it is 1, it will be 2, it will be 3 according to other convention I am saying, and this particular thing it will be 2 again. Okay, so like this it will be. So coefficients I told you. Now for neutron, this is the nuclear configuration. Now let us look at this particular nuclear configuration carefully. Just have a look at this. It has 2 number of nucleons, so paired up. It has 4 number of nucleons, so it is also paired up because 4 is even number. Over here 2 was even number. Over here also 2 nucleons are there, 2 is even number, so paired up. Over here also 6 number of nucleons are there, so 6 nucleons means paired up once again. And as it is paired up, so what will happen? It will yield you 0 spin. Okay, 0 spin and even parity. So no need to write with respect to neutron. No need to write with respect to neutron. In even odd nuclei, what is even odd nuclei? You can clearly see this thing. This is even and this is odd. Okay, so it is clearly even odd nuclei. So in even odd nuclei, that is number of protons is even, and number of neutrons is odd, or either number of neutron is even, number of proton is odd. Okay, both things can happen. Either Z can be even, N can be odd, or either N can be odd, Z can be even. Okay, so all these things are there. So in even odd nuclei, the ground state spin I and parity are determined by odd nuclei. So the odd nuclei, only proton has this odd nuclei over here. Okay, now I equal to J equal to 5 by 2. As already told to you, the value of ground state spin, the value of ground state spin is equal to what? The value of ground state spin is equal to this only. Okay, because it has unpaired nucleon, that is unpaired proton in our case. So what will happen? It will have the value of J, that is ground state spin I will be equal to J here. Okay, so I will be equal to J for this, and that will be equal to your 5 by 2. That will be equal to what? That will be equal to your 5 by 2. Okay, so this is the thing. And L equal to 2, clearly L equal to 2. How L is equal to 2? See over here, S, P, D and F. Okay, so 0, 1, 2 and 3. So for D the value is 2, value for L, small l, the value of small l for D is 2 clearly. For D the value of small l is 2. So over here the value of small l is equal to 2, and because unpaired nucleon resides in D subshell, so for unpaired nucleon the value of L is equal to 2 because it resides in D, so L equal to 2. So clearly L equal to 2. So parity will be equal to minus 1 to the power L, as already told to you. Okay, for even odd nuclei the parity is found like this, minus 1 to the power L. So minus 1 to the power 2 will come because value of L is 2. As the value of L is 2, so minus 1 to the power 2 will come, and that will be eventually equal to 1 because it has even parity. So that will be equal to your 1. Okay, so not because it has even parity, its value came out to be equal to 1. Its value came out to be equal to 1, that's why it is even parity. Okay, sorry for the mistake. Its parity came out to be 1, that's why we call it even parity, because whether you call the parity positive, whether you call the parity plus 1, or whether you call the parity even, all of them mean the same thing. Okay, so this is the thing. Now similarly sulfur 1633, what will you do? You can write the value of Z, that is atomic number for this sulfur S1633. What is the value of atomic number? The value of atomic number is clearly 16. And what will be the number of neutrons in this case? So number of neutrons will be 33 minus 16 clearly. You can from this, that is mass number, you can subtract the atomic number. Okay, so when you subtract 16 from 33, so number of neutrons, that will be equal to your 17. Okay, and Z is equal to 16, that is your atomic number. So this is what? This is even odd nuclei. This is clearly even odd nuclei. Okay, so this is what? This is even, and this is what? This is odd. So it is clearly even odd nuclei. Number of neutrons is odd. Now number of protons, as it is equal to 16, so it all of them will be paired up. All of the protons will be paired up because number of protons is 16, which is even number. As 16 is even number, so all the protons will be paired up, yielding you 0 contribution to spin. Proton, the contribution to spin by protons will be 0. because all the protons are paired up. Now remains the neutron. Neutrons are 17. So spin will be determined by neutron because the number of neutron is odd. Okay, so spin will be determined by neutron now. N equal to what? 1s half 2. You can write the nuclear configuration with respect to neutron now. This is the number of neutrons. So write the nuclear configuration with respect to neutron now. So 1s 1 by 2 2, 1p 3 by 2 4, 1p 1 by 2 2, 1d 5 by 2 6, 2s 1 by 2 2, 1d 3 by 2 1. This will be the nuclear configuration with respect to what? This will be nuclear configuration with respect to neutron. Okay, this will be what? With respect to neutron. Okay, so this is the thing. So now spin will be determined by neutron. Now clearly the unpaired neutron will go in the last. Okay, because all these are even numbers. You can clearly see after writing the nuclear configuration with respect to neutron, you can clearly see that this is what? This is paired up because number of neutron is even. So 2, that is all of them will be paired up. Then number of neutron is 4. Number of neutron over here it is 2. Number of neutron over here it is 6. Number of neutron over here it is 2. So what will happen? All of them will be paired up. As all of them are paired up, so what will happen? Clearly, as all of them are paired up, so it is very clear from that all of them will be not contributing to the ground state spin and parity. So only unpaired nucleon will contribute to that. So where is the unpaired nucleon? You can clearly see over here it is the unpaired nucleon 1d 3 by 2 1. This is the unpaired nucleon, that is unpaired neutron. Okay, so I equal to j equal to what? Clearly you can see that I equal to j equal to 3 by 2. Clearly over here it is 3 by 2. So the value of j is equal to I. Okay, the value of j for the subshell, the value of j for the subshell where unpaired nucleon resides, the value of j for the subshell where unpaired nucleon resides, that determines the ground state spin. So that's why the ground state spin is your 3 by 2. Now value of L is again 2 because clearly it is in D subshell, unpaired nucleon is in D subshell, and value of L for that D subshell is equal to 2. So S, P, D, F, according to that rule, value of L for D is, for S it is 0, for P it is 1, so for D it is 2, so L equal to 2. So parity will be what? Minus 1 to the power L. The parity will be what? Minus 1 to the power L. So L equal to 2, so you should put minus 1 to the power 2 over here, and minus 1 to the power 2 will be equal to plus 1. Okay, that is your even parity. Okay, so this will be what? This parity will be clearly your even parity, clearly. Okay, you can see this thing. So whether you call it parity equal to plus 1, whether you call it positive parity, or whether you call it even parity, all of them mean the same thing. All of them mean the same thing. Now let us move on towards our third example, which is argon 1841. Let us move on towards that. Now before moving on to argon 1841, I would like to tell you one thing. Okay, I would like to, as I keep giving you some advices also side by side along with all these videos, I also keep giving you advices. Okay, because my aim is not just to make you a civil servant or something like that. Okay, it is not my job to just make you a civil servant. Okay, of course that is my job, but still I have some other responsibilities as well. Okay, my other responsibility is that I want to make you all guys awakened citizen. Okay, awakened citizen. I would like to make you all guys awakened citizen. Okay, so that is the thing. So my advice to all of you is that you guys keep saying all those things, right? That many of the many of the YouTube journalists are just making a hype out of the situation or something like that. Okay, or when I made the last video about 2024 Lok Sabha elections, many of you might have felt that I am just hyping the content. Okay, or I am speaking about hyperbole. Okay, I am speaking hyperbolically. so that all of those things are wrong. Okay, it is just not true that we are being hyperbolite. It is not true. ठीक है ना, हम अतिशयोक्ति में नहीं बोल रहे. That's what I mean. Okay, the reality is indeed the democracy is indeed in danger, and whatever is happening in the country, no one is looking at that, no one is interested in that. Okay, that is the thing. So I also want you to make a good civil servant. Okay, not a communal civil servant or someone who is very arrogant. I don't want you to make all those type of civil servant. Okay, so that's why I also want you to be a good citizen of India. That's why I keep telling you all those things also side by side. Okay, so never take those things otherwise. But the last video which I made about the 2024 Lok Sabha elections, don't you think that Indian Express and The Hindu should have written some editorial of that kind? Don't you think Indian Express and The Hindu should have written some editorial of that kind? The things which I told in the last lecture, that is who will win 2024 Lok Sabha elections. You can find it on my timeline, on timeline of my YouTube channel. You can find that video. So don't you think Indian Express and The Hindu should have written some editorial on that? Don't you think so? The answer is yes, they should have written. But the thing is, they are also compromised. Okay, they have also been compromised. So that is the thing. Now Ergon 1841. Now Ergon 1841, let us look at this particular example. Now the value of Z, that is atomic number, it is clearly 18 because this is atomic number. Now number of neutrons will be equal to what? It will be equal to 41 minus 18. Okay, so number of neutrons 41 minus 18, that will be equal to 23. So clearly it is even odd nucleus. Okay, number of proton is even, number of neutron is odd. So number of neutron is odd, so no need to write with respect to proton because number of proton is even. So no need to write nuclear configuration with respect to proton. So only write nuclear configuration with respect to neutron because number of neutron is odd. Okay, so that's why only write nuclear configuration with respect to neutron. Now let us write it. So I am using another convention. Two conventions are there, so I am using the other convention. So 1s 1 by 2 2, 1p 3 by 2 4, 1p 1 by 2 2, 1d 5 by 2 6, 2s 1 by 2 2, 1d 3 by 2 4, 1f 7 by 2 3. Okay, now how this nuclear configuration with respect to neutron, that is 23 neutrons have been filled over here, but how have they been filled? How have these 23 neutrons been filled? Okay, the 23 neutrons have been filled in such a manner which was according to the energy level diagram, the energy level diagram of the nuclear shell model which we had drawn. This nuclear configuration with respect to neutron is according to that, the energy level diagram which we had already made, right? So this is according to that. Now, so clearly L equal to 3 over here. Okay, so you can see over here SPDF. Okay, S0, S has L value 0, P has L value 1, D has L value 2, and F has D value, F has L value equal to what? It is equal to 3. So unpaired neutron resides in 1f 7 by 2. Unpaired neutron resides in 1f 7 by 2. Okay, so as one unpaired neutron resides in 1f 7 by 2, the value of I equal to J, that is ground state spin, will be equal to 7 by 2 because the value of J for this is 7 by 2, and the value of L will depend on spectroscopic symbol. Spectroscopic symbol is F, so value of L is 3. So parity will be equal to minus 1 to the power 3, which is equal to minus 1. That will be again your odd. Okay, whether you call the parity to be negative or minus 1 or odd, it doesn't matter. So parity is odd over here, clearly. Now C612, let us look at this particular example. Okay, so Z equal to 6, so the number of proton over here is 6, so Z equal to 6. Okay, and number of neutron is equal to 12 minus 6, which is again equal to 6. So it is what? Even nucleus. It is even nucleus. So I value will be equal to what? It will be equal to 0 because number of proton is also even, number of neutron is also even, as both of them are even. So what will happen? The I value, that is ground state spin, will be equal to 0. Okay, and parity will be equal to what? Parity will also be even or plus 1. Okay, why it will be even or plus 1 or positive? Because we have already learned that when number of proton is also even and number of neutron is also even, in that case spin equal to 0 and parity equal to plus 1. We have already learned this rule. Okay, so why spin will be 0? It is very clear, because it is even number, it is also even number. So all of the nucleons will be paired up. Okay, all of proton will also be paired up and all of neutron will also be paired up. So I equal to 0, ground state spin will be equal to 0 clearly. Now parity equal to plus 1. Parity will be clearly equal to plus 1, and that will be equal to your even number clearly, always, because it is even. So parity will be equal to plus 1. Now N716, let us look at this particular example. N716, so Z equal to 7 clearly over here, and number of neutron is equal to 16 minus 7, which is equal to 9. So number of proton is odd, number of neutron is odd, so it is what? Odd nucleus. It is odd nucleus. Now it is odd nucleus, so the odd nucleus is there, so we have to write with respect to both. As it is odd nucleus, so with respect to proton also we need to write. Okay, just a second guys, just a second. Yes, so number of proton is also odd and number of neutron is also odd. As both of them are odd, it is odd nucleus. So what do we need to do then? What do we have to do in this particular case? Write with respect to proton also and write with respect to neutron also. Write the nuclear configuration with respect to proton also and write the nuclear configuration with respect to neutron also. You will realize. So with respect to proton, I have written 1s1 by 2 2, 1p 3 by 2 4, 1p 1 by 2 1. Okay, this is the thing. So Z equal to 7 is there. So the nuclear configuration with respect to proton, it will be like this. Okay, 1s1 by 2 2, 1p 3 by 2 4, 1p 1 by 2 1. And with respect to neutron, what will be the nuclear configuration? With respect to neutron, it is like this. If you draw the nuclear shell diagram, nuclear energy levels, then you will realize this thing. So with respect to neutron, 1s1 by 2 2, 1p 3 by 2 4, 1p 1 by 2 2, 1d 5 by 2 1. Now up to here you can see clearly, from here till here, all of the subshells have, all of these subshells have even number of nucleons, and from here till here all of the subshells have even number of nucleons. So their contribution will be 0 and their contribution will also be equal to 0. So just look at this particular subshell, last one, and this particular subshell. Now for odd nucleus, how to find the ground state spin and parity? How to find the ground state spin and parity for odd nucleus? That also we have already learnt. Okay, we have already learned that also. Now L1 equal to 1. So L1 means this is for proton, suppose. This is what? This is for proton, and this is what? This is for neutron, suppose. This is for neutron. So what will happen? So L1 equal to 1, J1 equal to 1 by 2. You can clearly see this thing, that L1 equal to the value of L for P is SP, so it is 1. L equal to 1. So L1 will be equal to 1 clearly, and L2 will be equal to 2 over here. So L2 will be equal to 2 over here, and value of J will be what? Value of J will be 1 by 2 over here, and value of J will be 5 by 2 over here clearly. So L1 equal to 1, J1 equal to 1 by 2, L2 equal to 2, J2 equal to 5 by 2. All these things happened clearly, you can see. Now parity, how is it given? It is given with respect to, and why L2 was 2? Because it was D symbol. Okay, this was for neutron, right? This was for neutron, so it was D symbol. That's why L2 was 2, and L1 was 1 because it was P symbol. That's why L1 was 1. So you can see L1 equal to 1, J1 equal to 1 by 2, L2 equal to 2, J2 equal to 5 by 2. Now parity, let us write it. So minus 1 to the power LP, this is what? This is your LP, this is your LP, and this is what? This is your Ln. Okay, so minus 1 to the power LP into minus 1 to the power Ln clearly this thing will happen. Just forget this, okay. So LP will be equal to what? LP will be equal to 1, and that is a writing mistake over there, okay. And ln equal to what? Ln equal to 2. So minus 1 to the power 1 plus 2, 1 plus 2 is 3, so minus 1 to the power 3, which is equal to minus 1, which is again odd. So parity is clearly what? Parity is clearly odd over here. You can see this thing clearly, very clearly. Now you can see that I had already told you to find out for odd nuclei, we have to first find out the value of J1 plus J2 plus L1 plus L2. For odd nucleus, we have to find this value, J1 plus J2 plus L1 plus L2. Or you can also call it J1 plus J2 plus LP plus Ln. You can also call it like that, okay, because L1 equal to LP and L2 equal to Ln, that's why. So J1 plus J2 plus L1 plus L2. Now J1 is equal to 1 by 2 and J2 is equal to your 5 by 2 and L1 is equal to your 1 and L2 is equal to your 2, okay. So when you add all these things, what is the value you get? J1 plus J2 plus L1 plus L2, what is the value? We get the value to be equal to 6. We get the value to be equal to 6, which is even, right? 6 is what? Even number. Even number. Now as 6 is even number, what will happen? As 6 is even number, so clearly the value of I will be given by J1 minus J2 in this particular case. So whenever J1 plus J2 plus L1 plus L2, whenever J1 plus J2 plus L1 plus L2 is even, what happens? Whenever it is even, then value of I, that is ground state spin, okay, that is given by J1 minus J2 mod, okay. Whenever L1 plus L2 plus J1 plus J2 is even, then value of I, that is ground state spin, is given by J1 minus J2. And whenever J1 plus J2 plus L1 plus L2, whenever it is odd, okay, when this particular entity is odd, okay, over here it is even, but when it comes out to be odd, then this value of ground state spin, this value of ground state spin is given by then J1 plus J2 instead of J1 minus J2, okay. So write a note over here that when J1 plus J2 plus L1 plus L2, when it is equal to what? Just a second guys, just a second. It is equal to what? It is equal to suppose odd. So what will happen? When it is odd, then I is equal to your J1 plus J2, okay. This is the thing which is there, okay. So this is the thing. And when it is equal to even, then what happens? You can see over here, okay. When it is even, then what happens? When it is even, you can see I equal to J1 minus J2. So 1 by 2 minus 5 by 2, that will be equal to 4 by 2, that will be equal to 2. So I equal to 2. So I equal to 2 for this particular odd nucleus, which is N716, okay. So value of I equal to 2 for this. Now C613, let us see this. For C613 you can see this clearly, that Z equal to 6, N equal to 7, okay, clearly. So even odd nucleus once again. So no need to write with respect to proton because number of proton is even. So no need to write with respect to proton. Just write with respect to neutron because neutron is odd. Number of neutron is odd. So just write with respect to neutron. Now N equal to for N, that is your with respect to neutron, C613 has nuclear configuration with respect to neutron as follows: 1s1 by 2 2, 1p3 by 2 4, 1p1 by 2 1. This is the thing, okay. Now 1p1 by 2 1 is there. Now parity, how will you give it? How will you give the parity for this? So clearly minus 1 to the power L is the thing which is written for parity. So clearly the value of L for this is what? The value of L, S is 0, for S value of L is 0, for P value of L is 1. So minus 1 to the power L, and the unpaired nucleon resides over here. So you can clearly see that minus 1 to the power 1 will come, because for p value of L is 1. Minus 1 to the power L and minus 1 to the power 1, it will be equal to minus 1 to the power 1. Okay, so minus 1 to the power 1 gives you minus 1. That is your odd. Okay, that is what? Odd. So parity is clearly odd over here. You can see this thing, that's for C613. Parity is what? It is odd. Okay, because the number of neutron is odd. So that's why parity over here has the last neutron goes in 1p 1 by 2. So parity is, that's why minus 1, because value of L is 1 for this thing, and minus 1 to the power 1 gives you minus 1. Okay, that is minus 1 to the power L, minus 1 to the power L gives you minus 1. So the parity is clearly odd over here. And spin will be equal to what? I equal to j equal to 1 by 2. Clearly this, the value of j is equal to 1 by 2 for this particular subshell 1p 1 by 2 subshell. Value of j is equal to 1 by 2, and only one unpaired nucleon is there. So I equal to j equal to what? 1 by 2. Clearly it is clear. Okay, so this is the thing. This is for C613. Now predict angular momenta, spin and parities of following nuclei. Again the same question. Boron 511, zinc 3067, bismuth 83209, copper 2963, oxygen 817. Clearly you can see. Now boron 511, what is value of Z? Z equal to 5. What is value of N? N is equal to 6. Okay, so whatever I say politically, it is not a hyperbole. Okay, it is not a hyperbole, it is a very, very true thing. Okay, and the democracy will be soon dead in India. Okay, I am giving you in written. Okay, along with my signature, just write this in your notebook, that democracy will be dead in India very soon, very soon. Okay, so that is the thing. So Z equal to 5, N equal to 11 minus 5, that is equal to 6. Okay, so it is what? Odd even nucleus. It is clearly, it is odd. The number of nuclei, number of nucleons over here is odd. That is, number of proton is odd. So odd, and the number of neutron is even. So odd even nucleus. Clearly. Okay. So you can write with respect to proton. No need to write with respect to neutron, because number of neutron is even. So as number of neutron is even, so all of them will be paired up. So no contribution in spin. No contribution in spin. So this will be, it is 6. So no need to write with respect to that. Now just write with respect to proton. Z equal to 5. So 1s 1 by 2 2, 1p 3 by 2 3. Clearly it is like that. Now L equal to 1. How? Because this is paired up, so no contribution, because there are two number of nucleons over here. So as the number of nucleons over there is 2, so both of them will be paired up. 1p 3 by 2 3, right? So it has the 3 is the number of protons in this 1p 3 by 2. Now L equal to 1, sp. So S has L value 0, S has L value 0, and P has L value 1. So for P, L equal to 1. Now J equal to 3 by 2 clearly over here. J equal to 3 by 2 clearly over here. So J equal to 3 by 2 over here. Okay, and these are what? 3 protons are filled up in this. 3 protons are being filled up in this 1p 3 by 2 3. Okay, so L equal to 1 and J equal to 3 by 2. So number of nucleons, that is number of protons being filled up is 3. So unpaired 3 is odd number, so unpaired proton lies over here. So clearly you can see this thing, that L equal to 1 for this because of P, and J equal to 3 by 2 because of this suffix. So parity will be equal to minus 1 to the power L, and value of L is 1. So minus 1, that will be equal to your odd number. Okay, and J is equal to 3 by 2 clearly. Okay, so I will be equal to J will be equal to 3 by 2 once again. I equal to J equal to 3 by 2 clearly. You can see this. Now similarly, no need to again and again tell all these things, but still I will tell you, because all these things have been asked to you in the previous years. So you can just note them down in your notebook and look at all these things. Okay. So zinc 3067, number of proton is even, number of neutron is odd. So even odd nuclei. Now clearly this number of this according to this neutrons, what will be the case? According to neutrons, the nuclear configuration of zinc, with respect to neutrons will be something like this. Okay, in examination do not write like this. In examination do not write 28 neutrons and then this and this. Do not write like this in your examination. In examination, by drawing the, in examination what should you do? In examination draw everything. Okay, like nuclear energy level diagram, you should draw it in the rough first of all. Okay, and after you draw the nuclear energy level diagram in rough, after that you should write the nuclear configuration sincerely. Okay, write the nuclear configuration sincerely, and after writing that sincerely, what should you do? After writing it sincerely, just keep in mind the exceptions, the various exceptions which I already told to you in the previous lecture. You should keep in mind those those exceptions. Okay, those exceptions you should keep in mind, and after keeping those exceptions in mind, what will be the case? Clearly it will be like this. Okay, 2p 3 by 2 4, 1f 5 by 2 5. Okay, so with respect to neutron, the nuclear configuration of zinc with respect to neutron looks something like this. Now over here what is the thing? Over here it has clearly what? It has clearly 4 number of nucleons. Okay, so it is paired up, so it is of no use. Okay, so just ignore this. This is magic number, so ignore this. Now just focus on this because it has unpaired nucleon. So unpaired nucleon means 5 number of nucleons are there in this. 5 number of nucleons are there, right? So 1f 5 by 2 5. So J equal to 5 by 2, so I will be equal to 5 by 2 because unpaired neutron resides in this 1f 5 by 2. L equal to 3 because of F. L equal to 3 because of F. For S, value of L is 0. For P, value of L is 1. For D, value of L is 2. For F, value of L is 3. Okay, so in that manner, and parity is minus 1 to the power L, right? Because it is even odd nucleus. Because of being even odd nucleus, parity will be minus 1 to the power 3. Because minus 1 to the power L and the value of L is 3, so minus 1 to the power 3 will be the parity. And minus 1 to the power 3 will give you minus 1. So whether you call the parity to be odd, whether you call the parity to be minus 1, or whether you call the parity to be negative, all of them mean the same thing. Okay. Now Bismuth 209. In this case, what should you do? You have to keep in mind the exception also in this. Okay. So Z equal to 83, N equal to 209 minus 83, that is 126. So number of neutron is what? Number of neutron is your magic number. Number of neutron is magic number. And what is number of proton? Number of proton equal to 83. It is not a magic number and it is odd also. So just try it with respect to proton. Just write nuclear configuration with respect to proton because number of proton is odd. Number of neutron is even. So no need to write nuclear configuration with respect to neutron. Moreover, with respect to neutron, there is also no need to write because it is also a magic number. Okay, along with being even number, it is also a magic number. So just write with respect to proton. Okay, so for this, with respect to proton, when you write 82 protons will be there in this. From here, it will be very long configuration. It will be very long configuration. So from suppose here to here, in 2 lines, it will be completed. So whatever the nuclear configuration is there for 82 protons, you should write it as it is by drawing the energy level diagram. So you should practice it in home. You should practice it at home. So 82 protons done. Then 1h 9 by 2 1. Finally, in the last shell, in the last subshell. Okay. So I equal to J equal to what? I equal to J equal to 9 by 2 clearly, because 9 by 2 is the value of J, right? 9 by 2 is what? The value of J. And value of L will be what? For H, the value of L is 5. The value of L is 5 for H, right? How the value of L is 5 for H? Because for S, the value of L is 0. For P, the value of L is 1. For D, value of L is 2. Then for F, value of L is 3. Then for G, value of L is 4. Then for H, value of L is 5. Okay, so clearly the value of L will be 5 for H. Okay, and 9 by 2 is the value of J. 9 by 2 is what? The value of J. So I equal to J, that is ground state spin will be equal to J for unpaired nucleon. Unpaired nucleon is there in 1H 9 by 2. So I equal to J equal to 9 by 2 clearly. So ground state spin is equal to 9 by 2 for this bismuth. And L equal to 5. So parity will be equal to minus 1 to the power 5. That is minus 1 to the power odd is odd. Okay, minus 1 to the power odd is what? Minus 1 only. Minus 1 to the power even is what? Plus 1. But minus 1 to the power odd is what? It is minus 1. Okay, so it is clearly odd parity. Okay, so for bismuth the parity is odd. Clearly, this is the thing. Now copper 2963. Clearly you can see that copper 2963 is there. Now Z equal to 29 for this copper 2963. Z equal to 29. Number of neutron is 63 minus 29, that is 34. So it is what? It is odd even nucleus. This is odd and this is even. So it is what? Odd even nuclei. Clearly it is odd even nuclei, right? So this is the thing. Now no need to write with respect to neutron. No need to write nuclear configuration with respect to neutron. No need to write it. Why? Because number of neutron is even. Okay, as number of neutron is even, so no need to write it, because it will be not contributing to the ground state spin and parity. Only protons will be contributing to the ground state spin and parity because of being odd in number. Okay, because of being odd in number, only protons are going to contribute in ground state spin and parity clearly. So it is odd even nucleus. So what is there? Okay, so you can clearly see this thing. Let me change the color of the pen because the color is different, so you can clearly see. Just see P. Okay, shells up to 28 proton, that is magic number. Then after that 2p3 by 2 1. So this is the nuclear configuration with respect to protons. Clearly you can see this thing. Okay, let me put it to the downward side. Okay, so 2p3 by 2 1. This is very clear, right? So odd nucleon is proton. You can see that the odd nucleon over here is 3 by 2. Okay, it resides in 2p3 by 2. So value of J for that is 3 by 2. So odd nucleon is proton clearly. So 2p3 by 2 1. So it is odd nucleon and that is your proton. So value of J is equal to 3 by 2 for this. And value of I will be equal to J, that will be equal to 3 by 2, because in 2p3 by 2 the last nucleon, which is unpaired nucleon, resides. And parity, as the value of L is what? Minus 1 to the power L is the parity. Now value of L is what? Value of L depends on spectroscopic symbol. So spectroscopic symbol S denotes L equal to 0 and spectroscopic symbol P denotes L equal to 1. So clearly the thing is, it is P. So L will be equal to what? L will be equal to clearly 1. So minus 1 to the power 1 and minus 1 to the power 1, that is minus 1 to the power odd is minus 1. Okay, so minus 1 to the power 1, as it is minus 1, so parity will be equal to odd. Whether you call it minus 1 parity or odd parity or negative parity, doesn't matter. It means all the same thing. All of them mean the same thing, whether you call negative parity or odd parity or minus 1 parity. All of them mean the same thing. Now 0, 8, 16, oxygen 817, oxygen 817. Okay, so Z equal to 8 and nitrogen, sorry, not nitrogen, number of neutron, what will it be equal to? So number of neutron will be equal to 17 minus 8, that is equal to 9. So this is even and this is odd. Okay, so this is even odd nuclei. Okay, so this is even and this is odd. This is even odd nuclei. Now number of neutrons. Okay, if we write the nuclear configuration with respect to neutron, what will happen? Writing the nuclear configuration with respect to neutron will give you something like this. Okay, as the nuclear configuration was short, so that's why it has been completely shown. Okay, now you can see that this has 2 number of nucleons, this has 4 number of nucleons, this has 2 number of nucleons. So all of them will be paired up, so no contribution. Only this has odd number of nucleons, that is 1. This subshell only has odd number of nucleons, that is 1. So it will be contributing to spin clearly. Okay, and how to write this nuclear configuration? No need to tell one no need to tell again and again how to write this nuclear configuration. You can watch the previous lectures and you can understand with the help of them. Okay, you have to draw the energy level diagram, nuclear energy level diagrams, and from that nuclear energy level diagram you write the nuclear configuration. Okay, it's very easy. So 1d 5 by 2 1 is there in the last. So odd nucleon resides in 1d 5 by 2 1. So clearly I equal to 5 by 2, clearly because value of J is 5 by 2 for this, and ground state spin is equal to, will be equal to J. Ground state spin is equal to J. So ground state spin equal to 5 by 2 because value of J for this is 5 by 2. And what is the parity? Parity as the value of L for D. Minus 1 to the power L is the formula for parity. How is parity found out? It is found out with the help of the formula minus 1 to the power L. And value of L for D is what? Value of L for D is what? For S, value of L is 0. For P, value of L is 1. For D, value of L is 2. So minus 1 to the power 2. Okay, and minus 1 to the power 2 is equal to E1. Okay, it will be equal to plus 1 clearly. So E1 parity. Okay, plus 1, that is E1 parity or positive parity. Whether you call positive parity or E1 parity or plus 1 parity doesn't matter. So 0817 is also done. Okay, now electric quadrupole movement onwards. Electric quadrupole movement onwards we will look in the next class. But all those things you should keep in mind that indeed it is a very dangerous situation for India. Okay, right now at present. Okay, so thank you very much.